Okay, let's get started. Good afternoon and welcome to this Oasys Gofer webinar. My name is Norbert Kovac and I am a business development manager at Oasys. Looking at the attendees, I see lots of familiar names as well as new ones. So just for the benefit of those who are new to Oasys, Oasys stands for Ove Arab Systems, and we are Arab's in-house software developer. We build structural pedestrian simulation and geotechnical software. I'm excited to see all of you join us for the first ever cloud-based software release, cloud-based FEA software release of ours. Just a few general notes before we start. You will be muted during the presentation. However, we do have a Q&A section, and if you just add your questions in there, we will answer these later on in the Q&A part. And moving on, as you can see on your screen, today's presenter is Mark Skinner. He's our Geotechnical Portfolio Product Manager. A few words about Mark. He's a geotechnical engineer by background and joined Arab in 2005. Spent 15 years working around the world on various projects, including 4 years in Australia and New Zealand. Building on a particular interest in automation and having used Oasys products to automate geotechnical analyses, he joined Oasys in 2020 as a portfolio product manager for our geotechnical software. He looks after the strategic direction of our products, and he is the product manager for Oasys Gofer. And joining in for the Q&A will be Carol Matthews. She is our geotechnical lead at Oasys. Carol is a civil engineer and she has a master's degree in hydrogeology. She worked on a number of ground investigation, highway and flood defense schemes before joining Oasys. Carol has been involved in developing Oasys's geotechnical software for over 30 years, and she has an extensive experience in finite element analysis, slope stability, retaining wall programs, and so on. Carol has also co-authored papers in numerical analysis, and she's a UK RI research panel member. And with that, let's get started today's session, and I will hand you over to Mark.
Brilliant. Thank you, Norbert. Just to check the screen is showing okay. Yeah, everything's okay.
Yes, can see it.
Fantastic. Hello, everyone. Yep. Welcome to this webinar, as Norbert said. Without any further ado, I'll move on to show you what we'll cover today. So obviously it's all about Gofer. We've broadly arranged the webinar into 4 sections. So a bit of a welcome to start with. What is Gofer? We'll then look in a bit more detail about what Gofer can do. We'll move on to have a tour of Gofer, just a basic model, show you how you get started, and we'll then do a bit of a summary, a bit of a wrap up, and answer any questions. So there we go. Okay, so welcome to Gofer. It's great, yeah, a privilege to be able to present about Gofer. So as Norbert said, our first cloud geotechnical product. So it's a bit of a milestone for Oasys. So I thought I'd start with essentially the question, what is Gofer? Well, it is our all new cloud geotechnical FEA product. We will look at what that means in more detail as we go through the presentations. But as a good summary, I think this sort of sums it up. So Gofer combines the benefits of cloud software with geotechnical FEA capability to unlock exciting potential. And it's really that exciting potential I'm most keen to show you today, and we'll show you a couple of aspects of that as we get into the presentation. But yeah, bear that in mind as we go forward. So if you've seen any of our articles, etc. so far, you'll see we've used the phrase FEA reimagined. We see Gofer as a bit of a reimagining of finite element analysis for geotechnics. So I thought I'd start by dwelling on why that is and what is different about Gofer in particular. So really there are 2 key aspects to that, and the first one is what this slide is showing, is that really we've tried to make Gofer as seamless as possible, made it easy to use and easy to learn to use. So we've spent a lot of effort designing it just to be that, so, to be easy to use, very easy to pick up, intuitive to get into, and I hope you'll see that reflected if you give it a try. I tried to sum that up in fewer words, and what I came up with, I've used this with the team, is the phrase elegant simplicity. That's what I hope will come through as you see Gofer. And really, we want this to be the go-to tool for sort of everyday analysis, and hopefully it being really easy to use is something that helps it be that. So that's the first aspect. The second aspect, what is different, is that we are leveraging cloud. So all the computing power is in the cloud, and that really gives us an opportunity to do things a bit differently. So on this slide here, we've got a few key points why Gofer being in the cloud would be different to a user, to you guys. So you don't install anything on a machine. You just open a browser and you log in. You don't need a powerful machine to run the analysis because we handle all that complexity in the cloud. So it doesn't need to be a state-of-the-art gaming machine or anything to get things running. You can look at results whilst your analysis is still running. So your analysis stages, you can look at the completed stages while the other ones are still going. It's very, very easy to share models. I think that's a good benefit. Just share a link and you can then pass your model to someone else. And really, you're always using the latest version of Gofer. It's a website fundamentally, so we can add new features and they just appear. We don't need to get anyone to install updates or anything like that. So sticking on the subject of how we're leveraging cloud, there are another main benefit, I suppose, and I think this is the real fundamental one, is that you can run multiple models at the same time. So if you're using it in the browser, you can have different tabs open, and I will show you that shortly as we get into Gofer. You can do different things in those different tabs. Obviously, you can only be in one tab at a time, but you could set one running and then jump onto the next one and make changes in that one. But it starts to get very interesting when you consider that Gofer has an API, and again, I'll come on to that later. And that means that you can trigger lots of analyses and then start to do quite interesting things like comparing options, varying parameters, as we've got on the slide there. Checking sensitivities of particular parts of the model. We currently limit to 3 concurrent analyses. They'll just start to queue after that, but we will start to expand that in the future, so you'll be able to run lots more at the same time. But again, we'll talk more about the API later and get into that. Okay, so they're the 2 sort of areas why we think Gofer is reimagining FE. We're going to move on now and have a look at Gofer's capability. So what can Gofer do? And you'll see there another phrase we've used in some of our articles and adverts and things. It's about making the everyday easier. So Gofer is at the simpler end of the FEA spectrum. We're not looking to do very, very complicated 3D models. That's not what Gofer's aimed at. We're looking to do these everyday design analysis tasks and make them seamless. So just bear that in mind as we look at these capabilities. What we can see on the screen at the moment are 6 boxes that kind of sum up the analytical capability of Gofer, where we've sort of pitched it. So I'll just run through them quickly. Top left, we've got the constitutive models that Gofer does. We've got linear elastic Moore Coulomb. We can do drained and undrained analyses. Gofer is a plane strain FE model tool. We can do construction stages, as you'd probably expect. We can also do CFI reduction, CFI analysis, as we call it, and we have steady state seepage in Gofer as well. Okay, so next set of capabilities, we're looking at things you can draw. So I want to give you an idea of the sort of things that we can draw in Gofer at the moment. Soil blocks, they're a given, so I haven't put a box on there modeling the soils that you need to model. We can do structures, loads, structural connections, if you like, pins and springs. They're in Gofer now. And we can also draw cross sections. Note especially that they are in the drawing section, not the results section. But again, we'll cover that later. So lastly, in terms of sort of routine capability, it's around collaboration. So there are ways of sharing a link. Well, you can share a link to a model, and someone else can pick it up and see what you've been doing, check out your results. But you can also download and upload files to Gofer, and they're just in a accessible JSON format, which is yeah, we'll come on to those with the API as well. It's also useful for using the API. So if you wrap all those capabilities together, that's a kind of a summary of where we're at in terms of Gofer's capability at the moment. We're really proud of this, but in its present form, but we would like to stress that we will keep improving Gofer. We're going to adding more features over time. There is more to come, essentially. So on the next slide, I really wanted to try and visualize the whole lot as a package, if you think of it like that. So we've got those analytical capabilities, set them in the cloud, and then set against that we have a web API, and that's where it starts to get exciting. I'll come back to that word in terms of what you can do with Gofer. Okay, so we're going to move on to a bit of a tour now. I've only got one slide for this, but because we'll jump straight into Gofer, and I'll show you the basics. It will be a very basic model, because there won't be time to show everything, but broadly we will cover the 4 key sections of Gofer, the tabs if you like. So overview, drawing a model, configuring stages, and results, analysis and results. So with that, I'm going to just stop this slideshow, switch into my browser, which is on the other screen. There we go. So that's our website. Come back to it in a second. This is Gofer. Just as a note, I'm using the Arab version of Gofer. So if you're not in Arab, don't type that link in because it won't work. We've got a separate link which we'll put in the chat at some point for people outside of Arab. So this is what you see when you log into Gofer. It's called My Models. This is a list of all my models. It's searchable. It's limited. It's presented in pages, so you can navigate around the pages. We can sort by name, when it was modified, etc. As needed. There is a second tab there for models that have been shared with me. We'll come back to that later. So I thought, as I say, the best way of showing you Gofer was to actually start drawing a model. So I've got a simple example on the screen that you can't see, and I'll try and draw that live. So first thing to do is create a new model. And you do that by clicking the new model button. And what we have here, just while I'm typing in a few starter details, is basically a model wizard, which is designed to get you started quickly with the overall extents of your model. So you can type in a width, a height, a number of soil layers, and the elevation, reduced level of the surface. And really what we're doing is setting up the outline of the model. So when I hit create, it builds me a new model, and you'll see there that I've got 3 layers, if you like. These are soil blocks of equal thickness. So hopefully that's a good way of quickly getting to the extents of your model. What I need to do now then is to start drawing on some detail, and I'm going to start with a structure, and I'll come back to soil blocks in a minute. Oh no, I'm not. I'm going to start by adjusting some nodes. That would make more sense. Come back to structure in a second. So the idea is that we can move these things around and get to the geometry we need to get to, in an easy fashion. I'm going to I just moved some nodes. I'm now going to split a soil block. I want to split. If I go back into element mode, I want to split this one. And what we can do is draw a cut line in front of the model. Position that. Oh, it happens to be at the correct level already. So go with that. Did it at Y is 7. So I've just cut that block in 2. The idea with these soil blocks is that we have a sort of cookie cutter mechanism. So if you draw a block, we can draw them as rectangles or as free shapes. The thing I've just drawn there is in front of the model, so I can move my block around and it's referencing the model behind. You see it's snapping to the lines. It's also snapping to a grid, which I've got switched on. If I were to, well, I'll do it. I'll press apply. That block is sort of cookie cut into the model, and where it overlapped a previous block, it's cut itself out. So I've got a new soil block there that's formed from the old one. And where it's outside the model, I've got an additional soil block. So if you were to keep doing that, you can quite quickly build up fairly complex geometry. I'll just show you a free form to show that it doesn't have to be rectangular. You can do what you like, really. So again, that is drawn in front of, but with reference to my existing model. I can snap to nodes if I want to. And as soon as I press apply, boom, that's formed. I can then continue to drag them around if I want, but they are now adjacent shapes rather than being in front, if that makes sense. So that's not a very realistic soil shape. So I'll get rid of those. And then I'll move on to the structure. So drawing a structure, I just select a structure from the top toolbar there. I'm just going to do a very simple, this model is just a flexible retaining wall. Again, I'm drawing my structure in front of the model, but with reference to it. I'm going to finish that line up there. I just want a simple vertical retaining wall. Press apply, it's drawn it. It's actually cut those soil blocks to match that structure as well. And then I enter some properties on the right here. It's all from memory. Hopefully they're semi-realistic. Let's go with that for now. Okay, structure one. I can give it a new name if I want to. Okay, so that's the structure, and I'll just show you as well, just as an example, we'll draw a line load, and it's the same sort of thing really, but the loads are positioned on edges. They can span blocks as well, but generally I put them on an edge. So you draw them, and then enter your X and Y components. Let's just put something in there for now, -10. Just going back to the soil blocks, I want to make an excavation, so I'm going to just draw a couple of 1 meter stripes here on the right. Let's do another one. Okay, so I did mention that I was going to go through these tabs in order, and I've jumped straight into draw model. So I will just show you overview, just so it's on the record. Model overview is where you can change the details that you enter in the wizard. So project number, name, any kind of description. You can also then share your model via overview as well. Alternatively, just copy the URL out of the browser and give it to someone. That will work. Okay, that's geometry, and that's really what drawing is about. It's geometry. We'll come on to configuring stages and materials in a second. Before I do that, I thought it would be good to show you as well where we can get further information. So the documentation for Gofer. So that's up here on the right. If you press help, first of all, you see a sort of pop-up which has some of the real key control definitions, I suppose. Down the bottom here, full documentation, you get a new tab. And this is all of the Gofer documentation, so the user guide. So it takes you through pretty much the stuff I'm showing you now. So how you log in, how you create a model, support tickets there, how you draw things. So that's some of the functionality I was just showing. Drawing soil blocks, moving nodes, splitting blocks, merging blocks, structures, pins and springs, how to import DXFs, drawing loads, applied displacements, etc. So it's all set out there. Hopefully you'll find that good to use. The second part, the later sections are all around materials, setting up construction stages. So well, as I say, we'll demo that shortly. And we'll come back to this documentation later because I want to show you the API. But just to acknowledge as well, we have a theory section which really sets out the technical background of the calculations. So the element formulations, the constitutive models that are being used. So that's where you find all of that information. And what I will show you as well at this point is the mechanism for getting help. So we can submit a support request direct from Gofer with the second button. This put in a subject and what the issue is, just like an email, I suppose, and that will come into our systems and get picked up. There is an option there, tick the box. If you're in a specific model, you have the option to send your model to attach it to the support. It's not really attaching it because it's in the cloud, so it's just sending a link. But that really helps, obviously, if there is a problem that you need a bit of help with. Okay, so we've got some geometry. What I'm going to do is cheat slightly and just jump onto a pre-prepared second example because I've been drawing random things. There we go. That looks vaguely similar, but a bit tidier. It's the same model in principle, but what I have done is pre-populated some materials because it would have been a bit. You don't need to see me enter 3 materials. I'll show you that now. So let's add a third material, which I've actually called rock. It's not especially descriptive, but it's just to show you the mechanism, I suppose, for entering materials. I've got some parameters on my other screen. So all you do is go through the various tabs as you might expect. These hopefully are fairly realistic parameters. Enter the details and press apply. Oh, there we go. So there we go. That was creating a new material. So my materials are saved in the tab on the right here. So what I've got now is my geometry defined, and I've got some materials. So the next step is configuring stages. So if I jump into that now, you'll see I've got one stage. This is where our construction stages are listed. This will be my initialization stage, where stresses are initialized. And what I'm going to do is just draw a box around the top layer, and I'm going to assign all those soil blocks sand. There we go. So that's that done. And middle layer, let's call that gravel, and then the bottom 2. So really, if I assign that to rock, whoops, did the wrong one. That's okay. We can fairly easily change to rock. So what I've got here is a wall slightly embedded in rock. You can now see. So the structure is off, the load is off. If I just select everything, you'll see the panel on the right responds to my selection, and it's showing me what's on and off, the buttons on the right. I can see the soil material assignments by the colors, and I can also, if I'd drawn any, I could assign groundwater to these blocks here as well. So you can draw groundwater profiles, but I haven't done that for this simple example. You can see down here that the load is off and the structure is also off for initialization, as you might expect. So the way to add the next stage is just hit the plus button. It takes an exact copy of the previous stage, or the stage that you're currently in when you press the button, and then you can start making some changes. So what I'd probably do in the next stage is, if I find the wall, I'll just turn that on. That's all we do probably. We do have the option to reset displacements, as you might expect, and this is where we control the analysis type. This is in the stage settings in the properties panel. Let's go for a third. I'll probably do some kind of excavation after that, and reset the displacements. And then, oh, I haven't named the stages. There we go. Dig. Let's set that one to all on, and then 4th stage, let's turn that load on, and we don't need to reset displacement. On. Okay, so that was really configuring the stages. So hopefully that shows it's quite a straightforward process. I know this is not a particularly complicated model, but yeah, that's how you do it. So what's next? So it is results. Well, we've called the tab results, but that's where you set the analysis going, and where when it's run, we'll be able to see the results. Let's set it going. But I have, as previously, I have already run the model in a new tab, just so you can see what it looks like. We'll leave that one going. It's now analyzing. Here is the same model already run, so you can get a quick overview of what the results look like, really. So we're in the 4th tab. When it's run, you'll see all of these the stage badges have turned green. That's the I have run color. And as you might expect, we can navigate the various results you might need. So you can change the variable, change the direction here, and see what's going on. I haven't mentioned that this black and white dash line, that is a cross section. We draw those in draw model, so that's the cross section there. That's again, as you might expect, that's a sample line for results. So let's just open that now. So this is sampling soil results along that line. Whatever we want to do, effective stress, YY. A feature I quite like is that the cross-section lines are not linked to the analysis, so we can draw more cross-section lines if we want. Again, they're drawn in front of the model, but with reference to it, so they'll snap around. Press apply, and then without rerunning, you can straight away see that cross-section is visible and available to interrogate the results of on the right. So when you make a change other than cross sections, Gofer will get rid of the results that you don't need. So if you made a change in stage 3 that doesn't affect the previous 2 stages, then it will keep those 2 stages results, and it will just get rid of the results that are dependent, follow the change you've made. So yeah, you just need to rerun if you did make one of those changes. But the point is, cross sections don't cause that to happen, so we can interrogate as required, I suppose. So I showed quickly changing the result. We can also change the result method, so we can plot some vectors instead of contours if needed. Scale those up a bit. Have a little look. Jump back to contours. We can also deform the mesh, and this is done independently of what result is being displayed. So obviously deform mesh is showing displacement. We could also be showing stress with the contours, and at the same time deform the mesh, if that it might be helpful in terms of interpreting what the model is doing. Last thing I'll show quickly on results then is the structure. So we can pull the graph up with the structure results. So say bending moment. It's not doing much this wall, but it's a test model. So that's all fine. So yeah, obviously you can see the results here, but you can also export an image, and that will just appear in your downloads folder, or you can export a CSV, and the same applies for cross sections. We'll do that. There we go. So that's a CSV that's come down into my downloads folder, and if I open that up, it will show you all of the structural results for that structure for this stage. So hopefully that's a good way of accessing those results if you wish to take them elsewhere and do something with them. Okay, let's try and think if I've forgotten anything for results. Hopefully not. I might think of something else. Let's just show you quickly. You can see the mesh if you want to. You'll notice it is refined. So we automatically refine the mesh around loads and structures and based on the size of the soil block. So you'll see I've got a structure here, so it's refining to that. These soil blocks have the smallest edge, so they'd form a base element size, and the load is also influencing that. However, if you wish, you can select a node and manually set an element size in meters, and it will then take that into in terms of how the results are, the mesh is refined. So you do have control over that. It's probably worth mentioning as well, boundary restraints, I didn't say that, but they are they're automatic, so don't need to worry about those. It's just applied restraints around the edge of the model to fix it in space. Okay, I think that's probably a good whirlwind tour of Gofer with a very straightforward example. I can hear a few bongs on it if there's any questions, but we'll get to those at the end. Let me just switch back to the presentation. There we go. And what I'd like to show next, it's still a tour, I suppose, but we're just going to touch on the API, which is an important part of Gofer. So again, this is really just an introductory slide. What I'm showing you here is the Swagger, which lists all of the endpoints of Gofer's API, but it's probably best if I just show you that for real. So before I do that, let's just jump back into the docs and jump into the API section. So what we've got here is information for anyone that wants to access Gofer via its API. It's just a REST API. I'll open the Swagger. This is a list of all the endpoints that are available. So you can see them there, and you can expand them, expand each endpoint, and it shows you the codes, response codes that are returned that are available to be returned when you query that endpoint, and it also shows you the structure of the data that is returned to you. So this one, what have we got here? Get models, and it will return the model ID, the model title, and the model description as a chunk of JSON that you can then deal with. So that's the case for all of these, and obviously the results one is a little bit more complicated because it's returning results. But yeah, hopefully gets the idea. Okay, so back to the docs. What we've provided in the documentation is some Python examples. Now there's two sections really, one for ARAP users, one for non-ARAP users, and that's just because the authentication is a bit different because we've got a separate version of Gofer inside ARAP, although it's the same except for the way you authenticate. What you can do is download the content of these boxes into files. It's explained in the documentation, and that will provide the building blocks to get into the Gofer API pretty quickly. And there's a few examples of doing specific things. So this one changes some structure properties, reruns analysis, and then pulls the results and actually plots a graph comparing them. So there's well, we hope there'll be useful examples of what to do to get started with that. So you need to download the authentication script and the configuration as Python files, put them next to wherever you're working and reference them into the examples. So yeah, it's all explained. But what I thought I'd show you was a quick example of the API in action. So this is Jupyter Notebooks. I like to use Jupyter Notebooks just because you can, well, you can see the result straight away, I guess. This is a very simple example. All I'm going to do is essentially acquire some structural results and plot them. If I just run these cells, and the first bits I'm doing are just handling the authentication and setting up a sort of outline function. So this function here, it assembles the query that's then sent to the API and returns the response. So I'll call that further down. So I've run those quickly just to get them done, but that's essentially what's available in the documentation that I just showed you. So the first real cell I'm going to show you then is querying a list of my models in my sort of version of Gofer. So I've just done that. I press run. There's a function here, just to explain it a bit more, that returns to a variable called model list the result of that query. So get v1 models, and if I jump back in, that's the one I just showed you. So it's returning me an ID, a title, and a description for each of my models. So it's found 21 models in my list. If I just jump into Gofer itself, you'll see I have 21 models. So it's got that right. And what I've done is just printed the second model in the list. I've printed the ID, which is the hash that goes in the URL that identifies that model, and I've printed the description, so test model. And what you should see, so bear in mind model number one is ID 0, number 0, so we've got 0, 1, 2, so that's the one it's picked. Well, it's the one I've told it to pick, and it's returned those details. Just for the purposes of example, I'm going to work with a specific model, which is a model that has is this one? It has a retaining wall and a little bund and a load. It's quite similar to the one I drew earlier, actually, but I've already captured the hash, so I know which one it is. So in the next little block of code here, what I'm going to do is use a different endpoint to to count the number of stages that have not been run. And I'm doing that by querying this endpoint and then basically running through each chunk of data it's returned and checking the code, or checking that the analysis code is not 0. So let's get that running, and it's told me that none of the stages are not run, so they're all run, and that's correct. You can see that they're all green, which is good. Right, so next block, I'm going to retrieve the results for the last stage in that model. And I'll set that going because it takes a few moments, because obviously there's a bit of data coming back there. So that's done using the, well, this endpoint here, getting results. So just jump back into the Swagger. That is this one here. So I have to form this query, sending a model ID and a stage ID. The stuff in curly brackets you have to enter. So that's what I've done there. I form that whole query. Model ID is what I've saved earlier, and last stage ID I've just grabbed from the previous data. And I have requested results of a type equals default, and then I've printed the nodal results that have come back as part of that JSON chunk of data. And I'm only printing below here, I'm only printing the 0th node result. So it's the first one in the list, just so that you can see what's coming back. So we've got a chunk of displacement data first, total displacement. So it's telling me the various components of displacement. Next chunk in the list. So it's just a standard JSON dictionary, and it's telling me stage displacement, and then I've got bending moment. So as it happens, the first node in the list is one of the structure nodes because it's got a bending moment. So on that note, the next thing I'm going to do is cycle through all of the nodes that have come back and pull out the ones that have structure or have bending moment. So you see, so I'm cycling through everything, and I'm saying if the bending moment is not equal to none, add it to a list. So, and just print complete to show that it's done. And then I'm going to plot those results on a simple graph, just an X versus Y graph. So we've got bending moment on the X-axis, and we've got vertical Y position on the Y-axis. So just to show you, hopefully, that it's fairly straightforward to do. If we jump back into that model, query the structural results, query the bending moment, you'll see that there's a nice match there. Maximum, well, it will match because it's the same data. We've got a max bending moment of about just under 53 kilonewton meters. Should be the same. Sorry if it's a bit small, but yeah, that's correct. So hopefully that is a good, very brief introduction to the API. The point is you've got those endpoints. Just jump back into the Swagger. You can both download and upload a model via the API, and because the entire model is a JSON, that means you can change anything. So you can essentially do whatever you like. However, if you break the model, obviously it will tell you there's something wrong with it. So within reason, you should be able to change anything via the API, and that opens up huge potential for automating with Gofer, really. There we are. Just while I remember, we do also have the ability to, I think I mentioned it, to down and upload files. So that's the button there to upload, and any model in your list, you can simply press the download button and it will come down into your downloads box. Cool. So that's that one. I'll just jump back into the presentation. Whoops. There we go. So that was the API. How do we get started? So Arup users, I've said that there's an internal version. Outside of Arup, we have a website, which is what you can see scrolling down now. And someone will put the link in the chat, I have no doubt, shortly. So what we've done, we've just launched Gofer. It's a new product. We have set up for now essentially introductory pricing. So we've got there three, call them cards, three types of sign up method at the bottom of the screen. In fact, why don't I show you the real website? There we go. So we've got three 3 cards here. You can sign up for a trial. That's a 14-day free trial. The only things you can't do with the trial are use the API or run multiple models. So pretty solid trial, I hope. And as I said, we're offering introductory pricing for 6 months just to get into Gofer. But my friends in the sales team will also be able to create enterprise accounts as well, which is it's basically a parent account with child accounts attached to it. So that's how you do it. And all you do is you press the button, enter your details, and that's how you create an account. So hopefully that's a nice easy way of finding Gofer. I will stick in the presentation this time. There we go. So lastly, that's pretty much it. A bit of a wrap up now. So I thought I'd wrap up with a few key points here. Fundamentally, we hope Gofer is something exciting and a bit different. We put a lot of effort into making it easy to use and easy to learn to use. We know it's an investment in time learning a new piece of software, but it really does leverage cloud, and I think it's not unreasonable to describe that as a next generation geotech analysis. We think it will make the everyday easier. So those everyday analyses we think Gofer will be useful for. And as we've just seen, got a web API, so we can power automation with Gofer and start to do some quite exciting things. It's that exciting potential. I think that's us. I've got a question slide here, so I'll hand back to Norbert.
Yes, well, thank you for that, Mark. That was brilliant, and it seems like it has stirred a lot of questions. So let's start off with the ones that we have in the Q&A. We will try to go through all of these during this session. However, if for some reason we can't cover something, we will reply to those via email. Okay, so let's start with Sina's question. Can we import DXFs instead of creating the model?
Yes.
I believe. Yeah, go on.
We can. So yeah, we can import a DXF. It has to have it's just a basic line type. We can't handle all of the. Well, Gofer will ignore anything that isn't a line essentially. But yes, you can import DXF. Yep.
Awesome. The next question is from Tarek. Can Anchor's soil nails be modeled in Gofer? Carol has already replied to this. Carol, is there anything you would like to add?
Yeah. Yeah, so we've got pins and rotational springs in the program already, and we're working on final testing of props to represent struts in the model. Soil nails are a little bit more complicated because you have issues like the bonded length and that sort of thing. So that would be a bit more work to implement. But yeah, I'm sure that would be of interest too.
Okay, and Carol, the next one is also for you from Tarek. How do you set up the mesh in the model? Is there a function of checking mesh quality?
Yeah, so Mark, actually, just as I was typing the reply to this, Mark was talking about the same thing in the presentation, so that was quite a coincidence. So we've got the auto refinement settings. So if you don't set the mesh size on nodes, it will take a sort of general, it'll divide the minimum dimension of the model by a number, I think it's 10, and then it'll refine extra smaller elements around structures and line loads and point loads. So if you don't set the mesh sizes, the program will try to give you a reasonable mesh, but you can optionally add a neighboring element size to any node and it'll use that instead. We don't currently have mesh quality checks, but as you can see, we've used this measure for a long time in a number of our programs. It's a third-party product and it's mixed quad and tri meshing. So the quads are 8-noded quads and the triangles are 6-noded triangles, so they have mid-side nodes. And the general sort of formulation of this measure is to produce quite nicely shaped elements. You tend not to get, very distorted shapes. So the quality is good. We do have some functions which can check mesh quality, and that might be something that we expose to users in due course. Yeah.
Brilliant. Next question is from Sasukantan. Have you implemented concept of interface element, contact surfaces between the soil and structure, or an equivalent feature in Gofer? Carol, I think you also replied to this one.
Yeah, I did a quick reply to this one, yes. So we haven't done this yet. We're looking at how best to do that, because obviously it's of particular interest around structures, and for example in seepage analysis where you want limited seepage boundaries and that sort of thing. So we are looking at that. It's quite high on our priority list. Yeah.
Brilliant. So moving on, because I see there are quite a few questions in the chat as well. Here it's a bit more difficult to track who answers. So if you have answered the question, just let me know. So the question is from Ying, how to add point loads, example load bending. And Carol again, very popular today.
Yeah, so yeah, point loads are available in the load drop down. So there's the point load, a line load, and you can add those at, as Mark said, at the edges of soil blocks. Bending, we're looking at adding moment loading in a future release, but we haven't finished that work yet, so that will come along in due course.
Brilliant. So the next question is from Karthik. Is it possible to copy user defined material from one model to another?
I can grab that one.
Yeah, sure.
It's not at the moment, but we're working on it. It's currently being developed, so we'll be able to download a material and then upload it again. Yeah.
I could add that you can do it. It's just not very straightforward. I guess it would just be a case of ask, but because you can download a model in JSON format, and then you could take the materials out of that and put it into another one. It's a bit of a manual process. But
if you're happy cutting and pasting the
cutting and pasting it. Yeah.
Yeah.
So it's feasibly possible.
Okay, so the next one is from Mehdi. I have some questions, but to start with, does it have dynamic or pseudostatic analysis? What happens if we close the browser? Can we come back and check its results later? And the third question is, does it have transient seepage analysis?
Okay, so I'll grab the first one. We don't have dynamic or pseudostatic analysis yet. Pseudostatic would be fairly straightforward, I think. So you basically apply a horizontal acceleration and it changes the force application. But no, we haven't put that in yet. As Mark said, we've concentrated on the sort of simpler end. When we did some research actually internally, we found that a large proportion, I think it was about 80% of FE analyses, were towards the simpler end of the spectrum. So that's where we focused the initial attention. And on transient seepage, we've got the steady state seepage analysis in there. So transient is going to be a progression of that, you know, with some of the settings for time stepping and so on. So yeah, that will come along in due course. And I think Tim's posted an answer to question 2 about closing the browser, so I'll let him pick up on that one.
Sure. Yeah. So I mean, this is the beauty of Cloud App, is that so 2 things. It auto saves, and somebody else was asking about this. It auto saves every couple of seconds as you're editing. So if you close your browser, you don't lose your work. But also, so when you send a model for analysis, it gets sent to the solver, which is running in the cloud, and then that just reports back a status every so often. So if you close your browser again, come back, it'll report what the current status is, and if it's complete, then the results will be available and you can get them anytime. You can basically hit run on an analysis, go home, come back the next day, and it'll be finished, and it's no need to leave your machine running overnight, kind of thing.
So the one I set going has finished, or had finished. There we go. Whilst we were working in other tabs.
Awesome. Moving on to the Next question from Andrew. Are you able to assign coarser, finer meshes?
So yeah, this is the same sort of question as the previous one about the mesh density. So you can set the mesh density at any node, and you can also select, you know, groups of nodes. When Mark showed moving nodes in groups, you can do the same thing. You can select a group of nodes and amend the mesh size on all that selected group at the same time. So you can edit things pretty much however you like as far as mesh refinement goes. Yeah.
Brilliant. The next question is from Karthik. Is the model auto-saved? If yes, what is the frequency? Tim has just answered that question, so that's covered. The next one is from Babika. How to set the analysis method for the soil structure interaction?
I wasn't entirely sure what the question meant. So is this related to things like interfaces between the soil and the structure?
Sure if we had any clarification further down.
So we can come back to that one.
Yeah,
Yeah, we can come back.
Babika,
Or if you
you're
want to
still
add
here,
some more
if you
detail,
can just
yeah.
clarify a bit on that. So the next one is from Ying. What about groundwater profile, especially if the PWP profile is not hydrostatic?
Yeah, so I answered that one somewhere. So you can set any number of water tables, and below each water table you can set a different gradient of pressure. So then you assign the water profile that you want to the individual soil blocks, so you can get that. You can get a subhydrostatic pore water pressure profile if that's what you want in a particular material. And there are some, there are other features for modelling undrained materials where the programme will calculate the excess pore pressure to keep the undrained material at constant volume, and that's taken into account as well. So that's like separate from the water profile definition.
I didn't really show steady state seepage, but these are flow boundaries on the left, and I've drawn a point flow boundary, so they're line flow boundaries. These are point flow boundaries, and if you see in the results, so I've just drawn the water down in that second stage. This is a quick demo. It's useful.
Yeah, brilliant. So the next question is the code editable? That is it possible to add function?
Yes, I answered this one. So the simple answer is no, but as I said in the answer, you know, a key aim we have is to be as responsive as we can to feedback. So please do use the feedback link. Tell us what you want in Gofer. I mean, obviously, if we get a huge number of feature requests, we can't do them all, but we will prioritize which ones will benefit the most people. But yeah, submit what you want to see in Gofer, and we may well be able to implement it. And you never know, maybe quickly within a week or two.
Indeed. Okay, next question is from Peter. What is the width of the soil slice in the 2D analysis?
Yeah, so I think, did you mean, Peter, that in the third dimension, sort of into the plane of the problem? Yeah, so that's 1 meter. So things like all the units are done as if it's a 1 meter thick slice.
Okay. The next question is from Gunjan. Is there any chance to expect more advanced soil models in upcoming Gofer versions? In brackets, like the models required for accounting stress dependency of stiffness moduli for the subsoil analysis?
I think the short answer is yes, and we're looking at ways to model more complex soil models. Yeah, something like a soft soil or hardening, that sort of behaviour, I think would be among the first that we'd look to add.
So the next question is from SK. Is there any option to analyze anchors or PVD to be introduced in the model?
So I think, Mark, you can maybe do a quick recap of what structural connections we've got.
So at the moment we have, I think I'm still sharing my screen, so we have a structure which is, you could approximate what you need to model to that structure. And in terms of connections, we have, they're not live at the moment because you need to draw the structure first, but you can see I can put a pin or a spring in. Props are not generally available yet. They'll be available very shortly, and node links will be coming soon. That will provide some functionality to represent ground anchors. If you know, so it's a representation of them. Theory, we don't have any dedicated sort of ground anchor elements or you know, geotextile elements yet. But if you can approximate them using the things you can draw, then that's where we're at, I suppose. But we're always looking to add more functionality.
Indeed. Great. So the next question is from Robert. Will a recording of this presentation be made available? It will be handy to have whilst using the Gofer demo. Actually, I can answer that. Yes, the recording will be uploaded onto our website, and we can send you the recording if you'd like. You can just drop any of us an email. Brilliant. Next one is from Babika. Can you demonstrate a simple geotechnical structure? I believe you've covered that.
Yeah. Hopefully we covered that in the demo. Just drawing a structure and interacting with it. Yep.
Babika, if there was anything in specific you were referring to, if you can just let us know. So the next question is from Camille. Is there any user guidance document which may have a few tutorials?
Right, so we're actually working on those now. So I showed you the documentation in its current form, but we've recorded some videos and they'll be added soon. So the idea is that there'll be little videos that focus on very specific subjects. So yeah, they'll be coming soon.
Brilliant. Next question. Can I define a pile that is next stage already cut? Demonstrate jacking process.
I think I'd have to try and understand more what was required before being able to answer that. So you might be able to draw several structures and turn them on in subsequent stages if that would capture what you need. Yeah. So
okay.
I think to do that.
Okay. Next question is from Ellen. Any comparison of Gofer with Plaxis 2D for accuracy?
Well, we've done, if I just show you the documentation again in the theory, there are in here, well, there's documentation about the solution methods. We wouldn't really tend to compare to a specific piece of software unless it was our own. But what we do have is, again, this is coming soon. We do have a number of validation models where we've compared to answers that have been published, for example, in papers. And I've got one on a tab here. This is a model that shows CFI analysis. So this model is a published model, Chowdhury and Zhu, 2005. So we were just showing that we get comparable results. And what we're planning to do is put those validation models into Gofer itself. So there'll be some new tabs appearing very soon with those validation models. So I hope that answers that question.
Brilliant. Well, we're reaching the end of our time. Maybe a few quick ones. Will you create an automated process to convert simple Gofer models into through?
That's a good question.
It's probably easier actually to do it the other way around, if that makes sense, because for Fru basically works with a world where there are only 3 parts, the wall and the soil on either side. And as you can see, Gofer is much more, fully featured than that. So it would be pretty easy to import the Fru geometry, the soil layers and the wall in the middle, and convert that into a Gofer model. I think to do it the other way around would be, you'd have to check whether, the data was going to conform with the Fru format and so on. So I suspect that we'll have some feature which will take elements of Fru and convert them to a Gofer model. And then you could compare the results between the 2 programs fairly easily.
Brilliant. Okay, well, we're already running over time, so I think we will end there. For all the other questions which we didn't manage to answer, we will send you out a more detailed reply in an email. Or if you have any further questions, you can just send these to oasys@arup.com. I would like to thank everyone for attending, and for our brilliant presenter, Mark, and Carol for answering all the questions, team, and everyone else who joined in. Don't forget to sign up for our free trial, which is for 2 weeks. And yes, you can keep in touch with us through Gofer. Well, I'm going to thank you for the time being, and hope to see you soon.